Hello guys, this is the continuation of the laws of indices. If you're joining this video for the first time, you can look at our previous videos for laws 1 and 2. This is law theory. Law theory is the powers of power. If you have a raised to power x and everything raised to power y, it is equal to a raised to power x times y. Let's look at an example. If 3 is raised to power 2 and is further raised to power 3, then we have 3 raised to power 2 times 3. This 2 multiplies 3 at the power, and that gives us 3 raised to power 6. Let's look at law 4, the powers of 1. Anything raised to power 1 is equal to that thing. So for example, if 25 is raised to power 1, that is equal to 25. Then the fifth law is the powers of 0. Anything raised to power 0 is equal to 1, provided that a is not equal to 0, provided that thing is not equal to 0. We're going to prove this in our subsequent videos, but for now, let's look at some example. This whole expression is raised to power 0. You don't need to consider whatever is here, provided it's raised to power 0, it means the answer is equal to 1. So you don't need to bother yourself to resolve whatever is in the bracket or whatever is here, no matter how complex it is, provided it's raised to power 0 is equal to 1. Let's look at the negative powers. A raised to power minus 1. The negative power is often referred to as the inverse power. So once you have a number raised to a negative power, the negative automatically creates an inverse. So a raised to power minus 1 is equal to the inverse of a. 1 over a is the inverse of a. Similarly, 1 over the inverse of 1 over a is a. So the negative power says that whenever a number is raised to a negative power, it automatically becomes the inverse of that number. Let's look at an example. 16 raised to power minus 1 is automatically the inverse of 16. Let's look at another condition. If a fraction is raised to a negative power, according to the inverse law, you also take the inverse of the number. So a over b automatically becomes b over a. Let's look at an example. If 5 over 3 is raised to the power of minus 1, because it's a negative power, we simply invert the fraction and the answer becomes 3 over 5. Let's look at another condition. If a number is raised to a negative power, multiply, and the negative power has a coefficient, then we take the inverse of the number and then we raise it to the power of the coefficient. So what it means is that if a is raised to power minus x, the minus forms the inverse as it were, and then it becomes the inverse of a raised to power x. Let's look at an example to get it clearer. So if 3 raised to power minus 3, the minus forms an inverse and then divided by 3 raised to power 3, and that gives us 1 over 27. Let's look at another condition. If a fraction is raised to the power of a negative number, the negative simply creates an inverse of that number. So a over b automatically becomes b over a raised to power s, what is left here, and that gives us b over a raised to power s. Let's look at an example. If 5 over 3 is raised to power minus 2, the minus creates an inverse, so we have 3 over 5, and we simply raise it to the power of the 2. And that gives us 3 raised to power 2, 9, and 5 raised to power 2 over 25. And the last law is the fractional power law. If a is raised to the power of a fraction, 1 over s, what happens is that the s forms a root of a. So a raised to power 1 over s becomes the s root of a. Let's look at an example. If 4 is raised to power 1 over 2, the 2 forms the square root of the number 4. And so we don't have to put the 2 here because this symbol here is the symbol of square root and it means 2. So we don't need to put the 2 here. So the square root of 4 is equal to 2. Let's look at another condition. If we have a raised to power x over y, the y forms the white root of a, while the s, the numerator, forms the power of the whole expression. And so if we have an example, 32 raised to power 2 over 5, the 5 here, which is the denominator, forms the fifth root of the number 32, while the numerator 2 forms the power of the entire expression. And so the fifth root of 32 will give us 2, which is what number would you multiply by itself 5 times to give you 32? The answer is 2 raised to the power 2, and that gives us 4. Let's look at another example. This time is a fraction raised to the power of another fraction. Similarly, the denominator of the power forms the cube root of the entire expression, 8 over 27, while the numerator of the fractional power forms the power of the entire expression. And the cube root of 8 will give you 2, which is how many times would you multiply 2? What number would you multiply by itself 3 times to give you 8? The answer is 2. And what number would you multiply by itself 3 times to give you 27? The answer is 3. So 2 over 3 raised to the power 2, and that gives us 4 over 9. 2 raised to the power 2 is 4, 3 raised to the power 2 is 9. Now try this. What would be your answer to question A and B? Put your answer in the comment section. Thank you.